Okay, and the lesson for today is 11-5, angle relationships in circles. In the past, we talked about angles that were on the center, angles that were right on the edge of the circle, and today we're going to get two more types of relationships. If a secant and a tangent intersect at the point of tangency, okay, that's a lot of words. Let's just think about what it means. If a secant, that goes through the circle twice. If a secant, like this, and a tangent intersect at the point of tangency, so that means the tangent is only allowed to touch the circle once, so I have to have it be tangent over here. If a secant and a tangent intersect at the point of tangency, then the measure of each angle is half the measure of its intercepted arc. Now, that's a lot of words, but really it's saying the same thing that you already know. When an angle is right on the edge of the circle, then the angle here is going to be half of the arc. Here's the arc. Remember, it's everything, every piece of the arc that's inside the angle, inside the edges of the angle. So this arc right here, whatever it is, this angle will have to be half of it. This angle is half. And it works on the same on the other side as well. This angle would be half of this arc as well. So suppose that this angle or this arc right here was 100 degrees, then this angle would be half. It's not really a new rule. They just write it out as a separate rule, but it's on the circle, so the angle is half of the arc. And we'll see examples like that. Keyword is that it's on the circle. They intersect on the circle at the point of tangency. It means that the angle equals the arc divided by 2. Doesn't change. Next rule is going to be where it's different though. If two secants or chords intersect in the interior of a circle, this is where it changes, in the interior of a circle. So we're looking at two chords or two secants or two segments that intersect inside the circle, but notice it doesn't say anything about the center. This is not a central angle. This is two chords that intersect somewhere inside the angle or inside the circle. It creates 4 angles right here. Here's what happens. The measure of an angle formed, let's look at this angle right here, is half of the sum of the measures of the arcs intercepted by the angle and its vertical angle. So when it's still taking half, the angle is still half of the arc. However, there are 4 arcs created here. So you have to pick 2 of them. The angle formed inside this one, or the arc formed inside this piece right here, gets counted, and the one across from it. Remember, vertical angles are across from each other like an hourglass or like a bow tie. So this arc and this arc, all you do is you add them together, divide by 2, and you'll have your angle, because the angle is still half of the arc, only this time there's 2 arcs to consider. So the angle is going to be half the sum of the 2 arcs, and it has to be the 2 arcs that are surrounding that angle. All right, so in this case, the key word is that the angle is formed on the inside of the circle, not the center. It means you take the arc sum, you add the 2 arcs together, and you divide by 2. By the way, this angle is going to be the same as this angle. Vertical angles are always equal. And the arcs are not equal because it's not on the center. Okay, we're going to practice that one in a second. This last rule that you need, if 2 secants, a secant and a tangent, or 2 tangents, anything that can be outside of a circle, if they intersect in the exterior of a circle, the key word there is that they meet on the outside. Interior means inside, exterior means outside. If these segments meet somewhere on the outside, it doesn't matter if it touches once, it doesn't matter if it touches twice. Okay, if it goes through a secant and a tangent, if they intersect somewhere outside of the circle, and then let's look at the rule. Well, think about it for a second. This one said When they're on the inside, you would have the sum. You would add two arcs together. So what's the opposite of inside? Outside. What's the opposite of adding? Subtracting. So whenever you have an arc or an angle that's formed on the outside, then the rule is going to be that you subtract the two arcs and you still take half. So it's the arc difference, subtracting two arcs and take half. Then the measure of the angle formed is half the positive difference of the measures of the intercepted arc. The way you can always make it positive is by going with the one farthest away first. It will always be the biggest one. So here's an arc. It has to be within the boundaries of the angle sides. So this one counts and this one counts. This arc right here doesn't count because it's not within the boundaries there. It's not within the angle. So all you do is subtract. You subtract the blue arc minus the pink arc, or you subtract the farthest away minus this one, or you subtract the bigger one minus the smaller one. Okay, but all you do is you subtract, take 2. So the rules are, when it's at the center, the angle's the same. When it's on the circle, the angle's half the arc. When an angle formed is inside, then you add two arcs together and you take half. When the angle's outside, then you subtract the two angles and take half. So you have a few examples down there on bottom that I do want to go over with you before you get to class tomorrow. So this angle 1 is right here. It's on the inside. Anytime an angle is on the inside, the rule is that the angle is the arc sum, add those together, and then divide by 2. So which two arcs are the ones that matter? The two arcs within the boundaries of those angles. So obviously this one right here, 40. And the other arc that matters is directly across from it. Those are the two that you add together. So the angle 1 is going to be the arc sum, 40 plus 52, and then you divide by 2. That is 92. Please correct me tomorrow if I do my addition wrong here. Divided by 2, and I don't want to do it wrong. I'm thinking it's 46. I just want to make sure. 92 divided by 2. Yeah, that's going to be 46. So angle 1 equals 46 degrees. Okay. All you do is whenever it's inside, find the two arcs that you add together and then divide by 2. This one is right on the circle. It's on the circle. The rule is that the angle equals the half of the arc divided by 2. So all you have to do is find the arc. The arc in this case that you care about is the one that's inside the boundaries of the angle, so it's this one. The arc is 134. The angle would have to be half of that, and just to make sure, I'm thinking it is 67. Let me make sure. 134 divided by 2. Yeah, so this angle is 67 degrees. So angle 2 equals 134 divided by 2. Angle 2 is 67 degrees. And the last one I want to look at is number 3, just to make sure that you've seen all these rules before you get here to school. This angle here is on the outside. Angle 3, the one they want right here, is on the outside. And there's a rule for when angles are on the outside. All you do is subtract two arcs and then divide by 2. It's the arc difference, and then you divide by 2. Be careful here. Before we do anything, we have to pick the two arcs that matter. And this arc right here is the first one you take. It's got to be the one farthest away from the angle, but it's got to be within the boundaries of that angle. 110 doesn't count because you have to be within this area right here, within the boundaries of the angle. This one right here doesn't count because it's outside of the angle. It's in the exterior of the angle. So this one in green also counts, but the problem is we don't know it. I want you to hit pause for a second and see if you can think of a way, looking at all the clues that you have here, see if you can figure out a way to figure out that green angle. Hit pause, try to figure it out before I tell you. Okay, did you figure it out? A whole angle is 360 degrees. And I know 3 of these pieces. I can find the 4th piece just by subtracting. So I have 360 degrees minus the ones that I know, minus 110, minus 100, minus 80, and I get 70 degrees. Careful, that's not your answer. That's just the green arc right there. That's that piece. For you, though, you need to do the rule for the outside. Subtract the 2 arcs and divide by 2. But now you know which 2 arcs to subtract. Whenever it's on the outside, the angle 3 equals 100 minus 70. Arc difference, subtract them and divide by 2. That would be 30 divided by 2. And angle 3 is equal to 15 degrees. Okay, go back and review this if you need to. Tomorrow in class, I'm going to be asking you to remember those 3 main rules. When it's on the circle, you take half of the arc. When the angle formed is inside the circle, you take half of the sum of the 2 arcs that are within the boundaries of the angles. And when the angle is outside the circle, you take half of the difference of the 2 angles, the ones that are bounded inside of the 2 arcs, the ones that are bounded inside of the angles. All right, that's it for today. Thank you very much.